Alright, I wanted to show you that first problem we worked in our in the last video using the box method this time. Again, you can decide how you wanna do it. It's totally up to you. I'll do it both ways. I'm comfortable doing it both ways. Alright, so what we're doing again is we have to start off by counting, but in this method we're basically boxing the atoms. I'm going to separate certain ones, but if there's a polyatomic, I'm going to keep the polyatomic together. And so that just makes it a little bit easier, I think, when trying to look at what we need and what we have and so forth. Okay, so I'm going to start off with this iron, possibly. So I'm going to start off with iron, and I have one. I'll make one box with iron. Then I have 2 hydrogen. I'm going to go ahead and separate those out. You can keep them together. Visually, it helps me see those separate. But this SO4, this sulfate, is a polyatomic, so I'm going to keep those together. I'm not going to draw it out SO or S O. I'm just going to leave it SO4. And I only have one of them. Alright. And then I'm going to draw my line separating my reactants from my products. Here I have 2 iron. I'm going to go ahead and separate those out. But I'm going to put them in one box. You can put them in separate boxes, doesn't matter. Whatever helps you visualize what you need to see. And that's really what the box method is about, helping you quickly visualize what you need to add. It just makes, maybe if you need to see it, this is the method for you. All right, now in this situation I have sulfate, but I have 3 of them. So I'm going to draw it out 3 times because I have 3 different sulfates here. 1, 2, 3. Again, something about putting them in boxes, it helps you visualize a little bit easier what you need. And then finally I have 2 hydrogens over here, and I do separate those out. It's not a polyatomic. Okay, so obviously the first thing that pops out at me is my sulfates. I have 3 of them here and only 1 here. And then I have 2 iron on the product side and only 1 on the reactant side. My hydrogens are balanced. Well, right away I'm going to want to balance my sulfates. And because I have 3 over here, I need 3 over here. And the coefficient that's going to help me get to that is 3. So I'm going to go ahead and put the 3 coefficient there. So now I've just added basically 2 more sulfates, and I don't need to count them out. I already know if I'm keeping them all together, right, that I have 3 of them. But I also added 3 of these hydrogen pairs. So I added another pair of hydrogens, actually 2 more pair. All right. So right away, looking at my hydrogens, I have 3 sets of hydrogens on the reactant side and only 1 here. So I know right away that I need to have a total of 3. And so I'm going to go ahead and add my coefficient 3 here, which means I've added 2 more sets of hydrogens to what I already had. Whoops. All right, and now The only thing I'm missing now, or that's not balanced, I have my 3SO4s, 3SO4s, 3 sets of hydrogens. I have 2 sets of iron and only 1 here, which tells me I'm going to need a 2 coefficient here in front of, well, that's not going to let me write it, a 2 here. Leaving me with another iron. And that's a box method. It's great when you have problems that are polyatomics. Instead of counting them and separating them out, you keep them together because they're going to stay together on the reactant side and the product side. Personally, I think box method can get a little confusing when you have all these boxes and then, you know, I'm just kind of visually counting them. I'm not writing down an actual number. But for some of you, that might work well. And so do whatever works best for you. Again, this is the first problem from the last video that I made showing you the box method. Hope this helps.